This is the first review session for the final exam. And actually, I will continue. So you will see that there are only 10 pages in here. So there are actually 8 questions in this slide, but I will continue with the second part of the review. It will have some more than 10 questions. And then whatever we will not finish during this session, we will just continue on the next session. Okay. So let us start. Factor the expression completely. So we have 3x squared y plus 17xy squared minus 28y cubed. So observe that y is a common factor. So you can easily factor that. You will have 3x squared y plus 17xy squared minus 28y cubed. Okay, so we factor y. We'll have y here, and then we have 3x squared plus 17xy minus 28y squared. And this guy here, this is still factorable. You remember the methods in factoring general quadratic expressions. So we have your A here, it's 3. B here, we can put B as 17y. So let us include the y there. Okay. Let us include this y here. And then you have C. This is 28 or minus 28y squared. So we want to find small a and small b such that the product capital AC, this is equal to small ab, and that a plus b, this is equal to capital B. So in here, capital AC, this is equal to what? 3 times negative 28y squared. So this is equal to negative 84y squared. Okay. And then you have here capital AC, you have small a, small b, and then small a plus small b, this is equal to capital B. Let's write capital B here. It's 17y. Okay? So capital B, it's 17y. So you expect that small a and small b will have factor y. Okay? You have y there and y there. So your job now is to find factors for negative 84. Negative 84, so that when you add a plus b, you will get 17y. Okay? So what are some factors? So in here, you have capital AC. All throughout this is negative 84y squared. So negative 84, maybe we can use what? 42. And so 42 and then 2. Okay? You can try 42 and 2. Let us put the negative on 42. So if you add them, you will still get negative value. But you will see that this is negative 40y. So this is not equal to 17y. Okay? So let us again use some more factors in here. So we want 17y. We want 17y. So in here, we can use negative 21y or positive 21y and then negative 4y. So if you multiply negative 4y times 21y, that will give you negative 84y squared. And if you add the two, you will have 17y. So which means that this is the pair that we need, which means that this guy here, okay, this guy here, let me just put this border here, you have y times 3x squared minus 4 xy plus 17xy minus 28y squared. So take note, the x, it's still there, okay? It's still there. So don't forget that x factor. Then you group this and also this. So you can now write. So for this group, we can factor out x. So if you factor x, you will have 3x minus 4y for the first group here. And then for the second group here, what can we factor? Sorry, why is this 17x? It should be 21xy. Okay, 21xy. So it's from this guy here. So for this group, we can factor out 7y. So plus 7y, and what will remain inside are 3x and minus 4y. And as you can see now, this and this, okay, they are just the same. So it's a common factor and you can factor that out. And finally, you will just have y times 3x minus 4y times x plus 7y. So this is the factored form of the original expression, 3x squared y plus 17xy squared minus 28y cubed.
Sorry, sir.
Next problem, factor the following expression completely. So in here we have x to the 4 minus 3x squared minus 4. So you have here x to the 4, there is no x cubed term. We have x squared, there is no x term, and then we have the constant. So this is a expression quadratic in form. You can do your factoring immediately using this expression, but if you can see the factors immediately, you can do some substitution first. Maybe you can let y equals x squared. Therefore, you have your y squared. This is equal to x to the 4. So from here, you can rewrite this as y squared minus 3y minus 4. Okay? And then you can easily factor this. Okay? You can easily factor this, but for the sake of reviewing the methods that we can use, let us write the details for that. So this time you are factoring quadratic expressions of the form t squared plus bt plus c. So here, capital B, it's your negative 3. Capital C, it's negative 4. So you need to find small a and small b such that your product AB, product small a, small b, this is capital C, which is negative 4, and the sum a plus b here, this is equal to negative 3. So you have your C, then you have your A, you have your B, you have A plus B here, which is capital B. Your capital C, it's just negative 4. So you can use 2 and negative 2. If you add these two guys here, you'll just get 0, which is this is not equal to your B. But you can also use 1 and negative 4. And if you use this, you will get your negative 3. And this is your capital P. Which means that this guy here becomes y minus 4, y plus 1. Okay? And then don't forget to bring the original variable x back in the situation or in the scenario. So we will have here x squared minus 4. Then here you have x squared plus 1. Okay? And again, you can factor x squared minus 4 easily using the quadratic difference of two squares. So if we recall that, you have some, say, u squared minus v squared. This is equal to u. Let me just move this. This is just u plus v times u minus v. So we can use this formula here for this part here. 4, it is equal to 2 squared. So using the difference of two squares formula, we'll have x minus 2 times x plus 2. And of course, you still have that x squared plus 1. So this is the complete factored form of x to the 4 minus 3x squared minus 4. Okay? Next, simplify and express the final answer with positive exponents only. So for this, we recall laws of exponents. Okay? So let me just write some of the exponents that, or some of the laws that we will use. We have a to the n times a to the m. This is equal to a to the n plus m. You have a to the n over a to the m. This is a to the n minus m. You have a to the n times to the m. This is equal to a to the n m. We also have ab to the n. This is equal to a to the n, b to the n. And of course, a over b to the n. This is a to the n over b to the n. And then some more. Maybe let's write a to the 0. This is equal to 1, assuming that a is not equal to 0. Okay? Maybe let's also write a to the negative n. This is 1 over a to the n. Again, assuming a not equal to 0 here. In here also, a not equal to 0. What else? In here, b not equal to 0. Okay? So some of the properties that we will use in doing this problem. So let us do that. We have 2 here and then negative 3 here. So we just multiply the exponents. We'll have x raised to negative 6. For this, we have to distribute. And then and this one here, you have negative 1, so you also need to multiply that. The exponent of y here, it's 1. So if you multiply the 2 there, it's just 2. So for this, we will now have x raised to negative 2, then y squared. So that's in the numerator. Same is true for this. On the denominator, we distribute, okay, this negative 1. And then we will end up with x raised to negative 1, y raised to negative 2. So if we simplify all of the expressions here, we will have y squared. You have y squared, y squared again, okay? And then on the denominator, we will have here, we have x to the negative 1, but these expressions here, they will go down to the denominator, okay? So we will have now x to the 6, x raised to positive 2. So if we simplify everything in the numerator, we have y to the 4. On the denominator, so it's y to the 4 because you just have to add this and this. So that's 2 plus 2. It equals 4. For the denominator, you have x raised to, you have this minus 1 plus 6 plus 2. That will be 7. So denominator, it's x to the 7. So this is the final expression. Okay. Next problem here. Rationalize the denominator and simplify. So first, let us start with square root of 20 in the numerator. Okay. So 20, it's 4 times 2. So square root, sorry, 4 times 5. So square root of 20, this is just square root of 4 times 5. And square root of 4, it's just 2. So you can simplify this as 2 square root of 5. Okay? So let me rewrite that first. Square root of 20, it's 2 square root of 5. And then on the denominator, we have 4 minus square root of 5. Now, you have a radical on the denominator. So, and it's a binomial, meaning it has 2 terms, right? What we're going to do is to multiply by the conjugate of the denominator, both the numerator and denominator. So we have minus in here. So we multiply the plus part or plus counterpart. So we multiply by 4 plus square root of 5, both the numerator and denominator. Okay? So for the denominator, you will just have 4 squared minus square root of 5 squared. For the numerator, let's just distribute. Let's just distribute this, okay, over the sum there. So you will have 8 square root of 5 plus you have 2 square root of 5 square root of 5. And of course, square root of 5 square root of 5, that's just square root of 5 squared. Okay? And square root of 5 squared, that's 5. So in here, in the numerator, you will have 8 square root of 5 plus, for this, square root of 5 times square root of 5, that's 5. And you have times 2 here. So you will have 10. And then on the denominator, we'll just have, so 4 squared, that's 16. And then square root of 5 squared, that's 5. So 16 minus 5 on the denominator. And simplifying this, we have 8 square root of 5 plus 10 over 16 minus 5, that's 11. So this is the final expression. Okay? Next problem here, perform the indicated operations and express the final answer in lowest terms. Okay, express the final answer in lowest terms. I would like to add an additional instruction here. So express the final answer in lowest terms and keep all expressions in factored form. So do not multiply them. What you actually need to do is to factor the expressions in the end. Okay? So know when to do the multiplication. Okay? And then factor once you have the final, say, polynomial in the numerator and denominator. If it's still factorable, you factor them. Okay? So here we have 2y over y minus 3y plus 3. And then plus 1 over y squared plus 5y plus 6. So first thing to do is to get the LCD. Okay? To get the LCD of the expression here. And in order to do that, you need to do some factoring for this part. So let us do factoring first there. We have y squared plus 5y plus 6. Okay? So this guy here, we have y plus 2, y plus 3. So let us just write the complete method or complete steps on how to get this expression here. Okay. So in here, you have your capital B equals 5, capital C equals 6. So you need to find A, B, such that the product AB, this is equal to C, and the sum A plus B, this is equal to capital B. So C here, you have A here, you have B here, and then A plus B equals capital B. So capital C, that's just 6. You can use 3 and 2. And if you add them, that's equal to 5, which is precisely your P. So that's why you have y plus 2 times y plus 3. So we rewrite that 2y over y minus 3, y plus 3, plus 1 over y plus 2, y plus 3. And now we find the LCD. So we see these factors, y minus 3, y plus 3. Here you have y plus 2 and y plus 3. Okay? So the factors are y minus 3, y plus 3, and y plus 2. And then with each factor here, the highest power that we see is 1. This is y minus 3 to the 1, y plus 3 to the 1 there. In here, you have y plus 2 to the 1, y plus 3 to the 1. So you multiply these factors and you put the highest power that you see for each factor, and that will be your LCD. So when we combine this, okay, into a single fraction, the denominator becomes y minus 3, y plus 3, y plus 2. And then for this guy here, of course, you have your 2y. Its denominator, you have y minus 3y plus 3. So you got these two guys here. You are missing y plus 2 here. So you multiply this by y plus 2. And then you have plus for this. So you got plus here. And then you have 1 here. So 1. And then the denominator of this expression here, you have y plus 2 and y plus 3. You have y plus 3 here, you have y plus 2 here. You are missing y minus 3. So you multiply 1 by y minus 3. Okay? Now, this is the time you'll do the multiplication in the numerator. So you can simplify the expression in the numerator. For the denominator, you keep that in factored form. Okay? So for the numerator, you will have 2y squared plus 4y. Okay? So we just multiply this over this sum. And then, of course, for the other guy, we'll just rewrite y minus 3 because it's just being multiplied to 1. And then for this, what do we get? Oh, let's write the denominator. Denominator, you still have y minus 3, y plus 3, y plus 2. Then if we simplify the numerator, we'll have 2y squared plus 5y minus 3 divided by y minus 3, y plus 3, y plus 2. And then at this point, you need to factor the expression in the numerator if it is factorable. Okay? If it is factorable. It is factorable, okay? You can check your b squared minus 4ac. You can check the discriminant, okay? If you check the discriminant, you will get a perfect square, okay? But we can use the method. Remember again the method for the general quadratic expression, okay? Factoring general quadratic expression. So this time you have capital A. So let me write the expression. 2y squared plus 5y minus 3. So in here, you have capital A equals 2, capital B equals 5, capital C equals minus 3. So capital AC, this is minus 6. Okay? And then you need to find small a, small b, such that the product small a, small b, this is capital AC, and the sum a plus b, this is capital B. So again, you have capital AC here. This is A, this is B, this is A plus B. Capital AC, that's negative 6. Okay? And then we need a 5. So maybe we can have 6 and negative 1 in here. you add them, you'll get that 5. So the factored form of 2y squared plus 5y plus or minus 3, okay? You can now rewrite this as 2y squared plus 6y minus y minus 3, okay? And then you can group this together and this together. For the first group, you will be able to factor out 2y. What will remain inside is y minus or y plus 3. For this group, you can factor out negative 1. So you will have negative 1 times you have y plus 3. Okay? So factoring completely, you have 2y minus 1 times y plus 3. Okay? So in the numerator here, we can now replace 2y squared plus 5y minus 3 by 2y minus 1 times y plus 3. And then on the denominator, we'll just copy y minus 3 times y plus 3 times y plus 2. And now we clearly see that y plus 3 cancels in the expressions, which means the final expression will be 2y minus 1 over y minus 3 times y plus 2. So this is the final expression. Okay? Okay, let's do this next problem. Simplify. 3k minus 1 times k minus 3 over k squared plus k minus 12 divided by 9k squared minus 1 over k squared minus k minus 20. Okay? So in here, you need to factor each expression, okay? And do the cancellation once you have factored them. Okay? Because you need to simplify. You need to simplify. So let us do all the factoring things here. Let us start with k squared plus k minus 12. Again, those little details, let us do that. You have capital B equals 1, capital C equals minus 12. So in here, you have capital C, then small a, small b, then a plus b. This is capital B. Capital C, it's AB. So here you got negative 12 for capital C. Let's choose the correct pair here. We have 4 and negative 3. So if you add them, you'll just get positive 1, which is precisely the B. So for this, you have k plus 4, k minus 3. It's the first. Second one, you have k squared minus k minus 20. So as usual, negative b or b equals negative 1, c equals negative 20. So in here, you have capital C, which is equal to small a, small b. Then small a here, small b here. And then small a plus small b, this is big B. So this is minus 20. And let's get the correct pair here immediately. We'll have negative 5 and positive 4. So if you add them, you'll get negative 1. So for this, you have k minus 5 times k plus 4. So that's the factored form. And then let's factor 9k squared minus 1. This is just 3k quantity squared minus 1. So difference of two squares, you'll just have 3k minus 1, 3k plus 1. So everything here, I mean all the expressions here, this, and this can be factored now. We can now write their corresponding factored forms. And here you have division, so if we convert them to multiplication, or if we convert this to multiplication, we have to get the reciprocal of this, which means let's copy 3k minus 1 times k minus 3. Denominator, you have k squared plus k minus 12. We were able to factor that into k plus 4 times k minus 3. Division, we change that to multiplication. We get the reciprocal of 9k squared minus 1 over k squared minus k minus 20. So for the numerator, we have k squared minus k minus 20. It will go to the numerator. Factored form is this. So we have k minus 5 times k plus 4. And for the denominator, we have 9k squared minus 1. It will go to the denominator here. And we were able to factor that into 3k minus 1, 3k plus 1. And now we are ready to cancel expressions that we can cancel. We have k minus 3. We have 3k minus 1 here. And we have k plus 4. And we are left with k minus 5 divided by 3k plus 1. So this is the final expression. Next, simplify the expression. Assume that k is greater than 0. Okay? We assume k greater than 0. So we need this assumption because we have 27k inside a radical. So if k here it's negative, then you will have radical of negative. I mean square root of some negative number. So we cannot have that. Now, for this, let us try to simplify the expression here. Note 48, this is equal to 16 times 3. Okay? So if you get the square root of this, you'll just get 4 square root of 3. And of course, if you have 48k cube, you get the square root of this. This will just be 4k k square root of 3k. Because, well, k here, I mean k cubed there, is equal to k squared times k. So if you get the square root of that, k squared k, you'll just get k square root of k. And then we have 27k there. Okay, you want the square root of this, but 27, it's 9 times 3. So 9 times 3 times k, and square root of 9, that's 3. So you will have 3 square root of 3k, which means this expression can be rewritten as 4 times 4k square root of 3k minus 3k times 3 square root of 3k. Okay? So simplifying, we'll get 16k square root of 3k minus 9k square root of 3k. And these two guys here, they are like terms. So we can just combine the constants. And we will end up with 7k square root of 3k. So this is the simplified version. Okay? Next problem, simplify and express the final answer in lowest terms. So we have here complex rational expression. So for this, we have this numerator 6 minus 3 over x. And then this denominator here, it's 2x minus 1 all over 4. So we can convert this to multiplication. Okay? But first, we need to combine this into a single rational expression so we can do some canceling if needed. For this guy here, okay, you can rewrite that as, so you have the denominator x, and you just have 6 in here. So we need to multiply the 6 with x or by x. So you will retain 6. And then, of course, you have the minus 3 there. And then, on the denominator, you still have 2x minus 1 over 4. For this guy, you can factor out 3. Okay? And then from division, let's just write this in multiplication form. So we need to get the reciprocal of this. So let us do all of that. First, we factor 3 from this expression. We'll just have 3 times 2x minus 1. Denominator, it's still x. And then we have the multiplication. And then the reciprocal of this, it's just 4 over 2x minus 1. And here you see immediately that this guy here and this guy here, they will just cancel each other. So we cancel them, and you have here 3 and 4, you just multiply. The denominator, it's just x. So this is just 12 over x. So this is the final expression. Okay. Use factoring to solve 3x squared plus 17x minus 28 equals 0. Now, if you are asked to use a specific method, you have to use that method. Otherwise, you won't get any point. Okay? Even if your final answer is correct. Or maybe I could give you 0.5 over 5 points, But you see, the reason why we write these specific instructions is because we want to know if you know that method. Okay? If you know how to do using that particular method. So let us factor 3x squared plus 17x minus 28. Again, general quadratic expression in here. So let's use that method. So you have a equals 3, b equals 17, c equals minus 28. You have capital AC, that's 3 times minus 28, and this is equal to minus 84. Capital B, that's just 17. Okay? If you recognize that this expression is very much similar to the first problem that we did, then that's good. Okay? Because it is similar to that. Okay? But for the sake of this review, again, we will write all the details. So you have your capital A times capital C. This is equal to small a, small b. You have A here, you have B here. I mean small a and small b there. And then you have to add small a plus small b. This is capital B. Of course, this is minus 84. And the correct pair that we obtained earlier was minus 21. And then, sorry, it's plus 21 and then minus 4. So if you add the two guys here, you'll just get 17. So just like before, you have 3x squared plus 21x minus 4x minus 28. Okay? And then grouping. You group this. If you group that, you will be able to factor 3x. What will remain inside is x plus 7. And then the other group here, you factor out negative 4. What will remain inside is x plus 7 as well. So this guy here, we will be able to write as 3x minus 4 times x plus 7. Okay? Now going back to this expression here, we will now have 3x minus 4 times x plus 7 equals 0. Okay? And from here, we use the following property. Okay? So recall that if the product, say the product UV, this is equal to 0, then U equals 0 or V equals 0. Okay? Therefore, this means that we have 3x minus 4 equals 0 or x plus 7 equals 0. And this guy here, we will have 3x equals 4 or x equals minus 7. And for this first guy here, let's just write it now as x equals 4 over 3. And of course, the other guy here, it's just fine. So in here, we have the two solutions. Okay? Next, we have x plus 3 over 2x plus 2 equals x minus 3 over x squared minus 1. We want to solve for x. Okay? So you can do your cross multiplication. You can multiply both the left-hand side and the right-hand side by the LCD. Okay? You can combine them into a single rational expression. So you will have a rational equation. So you can have several methods to do or to use. So for this, let's just remind ourselves that we cannot have 2x plus 2 to be 0. We cannot also have x squared minus 1 to be 0. Okay? So we don't want these two guys. But for these two guys, this means that what? For the first one, this means you have 2 times x plus 1 not equal to 0, which means that for this, we cannot have x equals negative 1. For the second expression here, we cannot have x plus 1 times x minus 1 equal to 0, which means we cannot have x plus 1 to be 0 or actually and x minus 1 to be 0. Okay? So in here, we cannot have x to be negative 1 and x to be 1. So those are our restrictions. Okay? So what we're going to do is to multiply. So for the solution that I will show you, what we're going to do is to multiply by the LCD. The LCD, you can just look at the denominators again. So you have 2 times x plus 1 factors of this. And then for these factors are x plus 1 times x minus 1. So LCD, it's just 2 times x plus 1 times x minus 1. Which means we multiply both sides of the equation by 2 times x plus 1, x minus 1. So you have here x plus 3, and then you have here 2 times x plus 1. You multiply this by 2 times x plus 1, x minus 1. This is equal to x minus 3 over x squared minus 1. You multiply this by 2 times x plus 1, x minus 1. On the left-hand side, we'll be able to cancel 2 times x plus 1. On the right-hand side, we will be able to cancel x plus 1 times x minus 1 because that's just x squared minus 1. So if we simplify this, you'll just have x plus 3 times x minus 1 on the left-hand side. On the right-hand side, you will have 2x minus 6. Okay? Now let us expand the left-hand side. It's just x squared, so you can use your FOIL method. You will have your x squared. Then you have your x times negative 1. So let me write that. And then you have your 3x. So plus 3x. And then this guy here, you have minus 3. And then on the right-hand side, you still have your 2x minus 6. And then we simplify. We write all expressions on the left-hand side, and then on the right-hand side, we have 0. So we will end up with, we have here x squared minus x plus 3x. That's just 2x. Then you have the minus 3. And then for these two guys, we bring it to the left-hand side. We'll have minus 2x. And then you have here plus 6. And then, of course, this is equal to 0. So if we simplify this, we'll end up with x squared because this guy here will cancel this. And here you have minus 3 and plus 6. So we will end up with x squared plus 3. So x squared plus 3, and that's equal to 0. Okay? And of course, if you have some number, if you square it, it becomes greater than or equal to 0. So this means that this guy here has no solution. In fact, if you write this as x squared equals negative 3, then this means that it has no real solution. And that's it. So this is the final answer. So no real solution. Next problem. We have 9x squared minus 1, sorry, 9 raised to x squared minus 1 equals 27 raised to 3x plus 1. So we want to solve this equation. So observe 9 and 27 here, you can write it, or you can write them as powers of 3. Okay? So your 9, you can write it as 3 squared. And of course, you retain that exponent x squared minus 1. 27, you can write it as 3 cubed. And the exponent, it's just 3x plus 1. So if we apply laws of exponents here, you will have 3 times 2x squared minus 2. This is equal to 3 times 9x plus 3. Okay? And remember, if you have a to the n, this is equal to a to the m. So if we have this, then your n must be equal to m. So what does this mean? This means we must have 2x squared minus 2. This is equal to 9x plus 3. So we just have here a quadratic equation. So in here we simplify. We have 2x squared minus 9x minus 5 equals 0. You can do factoring if possible. But for this, I'll use quadratic formula. So you know, it's a good way of solving quadratic equations. So for the quadratic formula, you have a x squared plus bx plus c equals 0. Your x, this is equal to negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Okay? So for this, we will have x equals, you have minus b, so that's negative b, that's minus minus 9. Then you have plus or minus square root of b squared, so negative 9 squared minus 4 times a, which is 2, times c, which is negative 5, all over 2 times a. So in here, you will have x equals 9 plus or minus square root of negative 9 squared, that's 81, plus negative 4 times, okay, so it's minus, but we have 4 times 2 times negative 5, that's negative 40. So it becomes plus. And then here you have all over 4. Here you have 9 plus or minus square root of 121 over 4. And 121, you get the square root of that. That's just 11. So in here, you will have 9 plus or minus 11 over 4. So in here, you will have 20 over 4, or 9 minus 11, that's negative 2 over 4. So if we simplify this, you have 5 or negative 1 half. Okay? Questions? Next, solve for x. We have square root of x minus 1 minus square root of 14 minus x equals 1. So for this, my suggested step was to isolate one of the radicals in one side of the equation and put everything else on the other side. Then you do the squaring, etc. Okay? So we can rewrite this expression as square root of x minus 1. This is equal to square root of 14 minus x plus 1. And then we do the squaring here. So on the left-hand side, we'll just have x minus 1. On the right-hand side, we use binomial expansion. So we need to square this part here. That's just 14 minus x. This is plus. So we have plus. And then twice the product of this and this. So you just have 2 times 1 times square root of 14 minus x. Then plus, we have to square this. 1 squared, that's just 1. Okay? And then we still have one radical on this equation, which is this guy. So we isolate that radical again. We bring all other expressions to the other side of the equation. Okay? So if we do that, we will now have, so you have here x. On this side, you have minus x. So if we bring it to the other side, we'll get 2x. On this side, you have 14 and 1. That's positive 15. If we bring it to the other side, it becomes minus 15. So you will have minus 1, minus 15. That's minus 16. Then in here, on the other side, we'll just have 2 square root of 14 minus x. This guy here, it's divisible by 2. You have 2x, you have 16. You can factor out the 2. Okay? So if we divide everything by 2, we'll be able to get rid of this. We'll just have x minus 8 equals square root of 14 minus x. And then same process, we square this again, we square this again. On the left-hand side, we just apply binomial expansion again. We'll just have x squared. This is minus, so we have minus. And then twice the product of this and this. So 2 times x times 8, that's 16x. And then for this, we just square it. So plus 64. On the right-hand side, you have 14 minus x. And then we are now ready to solve this quadratic equation. So if we simplify, if we write the expressions on the left-hand side and 0 on the right-hand side, we'll just have x squared minus 15x plus 50. Okay? So minus 15x, because if we bring this to the other side, it becomes plus x. So minus 16x plus x, that's minus 15x. Here we have 64 and we have 14 here. So this 14, we bring it to the other side, that becomes minus 14. So 64 minus 14, that's 50. And this is equal to 0. From here, you can do your factoring, you can do your quadratic formula, okay? I'll just use factoring in here, okay? We will be able to factor this into x minus 10, x minus 5 equals 0. So you can do the details on the side. You have your b equals minus 15, c equals 50. So you have c equals small b, a, b, a plus b equals capital B. This is 50. You need minus 15 for capital B. Factors of 50, you can do 2 times 25. You can do 5 times 10. Okay? But we need negative here, and the product is positive. We can use both negative. So minus 5 minus 10. And this is equal to minus 15. That's why this is the factored form. Which means that in here, you have x equals 10 or x equals 5. Now, we added several solutions in here when we squared this and this. Okay, when we did this step, also this step, we added some solutions that should not be there. So we need to do the checking part. Okay, we need to do the checking part. Okay, so let us do this. If or when x equals 10, we will have square root of 10 minus 1 minus square root of 14 minus 10. This is equal to square root of 10 minus 1, that's 9, minus 14 minus 10, that's 4. So we have minus square root of 4. And this is equal to 3 minus 2, which is equal to 1. So we are good. When 10 or when x equals 5, when x equals 5, we will have square root of 5 minus 1 minus square root of 14 minus 5. So 5 minus 1, that's 4. So you have square root of 4 minus 14 minus 5, that's 9. So we have square root of 9. This is equal to 2 minus 3. This is equal to negative 1. And this is not equal to positive 1. Okay? Therefore, the only solution here is just x equals 10. And for this here, we say it's not possible, or we say it's an extraneous solution. Okay?